I'll introduce myself. My name's Tom Anderson. I own this company, Anderson Equipment Sales and Service. I've been doing drill rebuilds and repairs for other customers for a very long time, as long as I can remember, probably 40 years. During that period, I was a drilling contractor. I've spent many years doing blast holes and for mines and quarries, but for the most part, I've been repairing drills for other customers and buying and selling and refurbishing drills for my own company. This drill that we're going to be looking at here today is a Boart Longyear LF70. It's a helicopter portable rig. It comes apart in 7 different modules, which can be disassembled in about 1 hour by 2 guys and moved with a helicopter. They tell me as small as a Hughes 500. This particular rig, the potential customer, he acquired and desired a remanufactured or new engine. We took the original engine, or I did, which that's one of the things that we do here extensively is engine rebuilds. It's a Cummins 3.9. It's a BTA 3.9. It was completely overhauled. It's got all new parts in it, all new pistons. Sleeves were put in to standard. The head was redone, all the valves, valve guide seals, all new gaskets, oil pump, the fuel injection pump, the turbocharger, the injectors, everything was all remanufactured by qualified reman shops for the different components. It's been reassembled and it's been tested. It's a 116 horsepower Cummins 3.9. And as we went through the rebuild on this thing, or the refurbish, I'd like to say, everything was completely disassembled down to every component, winches, everything, all disassembled and inspected, and anything that looked like it needed attention, wear, or to be replaced has been done so. So basically what you're getting is a drill that's in very, very, very good condition and should have no issues whatsoever. And as I mentioned, we test it here for a long time before we let it go. What you're seeing right now is the rebuilt Cummins 4 BTA 3.9 Cummins diesel engine. And as you can see, it's been rebuilt here. At least you should be able to see that. The auxiliary pump for the hydraulic pump for the bean pump water pump system is right here. It's located right on the accessory drive, and the engine speed is controlled by this electro controller which moves the throttle lever and is controlled from the operator's panel. The engine is shut off with an electric solenoid, which isn't visible, but it's on the back side of the injection pump. This particular engine, we've added another primary fuel water separator, which is a Raycor filter, which is in front of the radiator at this time. In addition to rebuilding the engine, why we went ahead and had the water radiator rebuilt and the oil cooler checked and pressure tested. So we know that everything's good. All new hoses, all new belts. Everything is as brand new right now on the power unit. Now in this view, you can see the primary and the secondary hydraulic pump and how they're attached to the engine, directly coupled through a coupler that's on a drive adapter on the back of the flywheel. What I need to mention is every hydraulic connection and electrical connection is a quick connect, so that it's very easy and drip free to disassemble these modules when you're moving the drill. You can see the back of the hydraulic tank here and all the filtration that it has. It even has a high pressure filter which filters the oil coming out of the primary pump. The electrical controls for the machine are with a Canon type waterproof, dustproof connection. You can see the back of the control panel here and how the electrical connections are installed into the into the panel. The panel's waterproof and dustproof, and it includes a tachometer, oil pressure, water temperature, hour meter, and an amp meter. And it's all, the whole engine is protected with a automatic shutdown system. So should the sensors detect low oil pressure or high water temperature, it will automatically shut down. And it's also provided with an emergency shutdown button on the control panel and a satellite remote control panel, which I'll show you in another clip, that you can position anywhere around the drill for a helper or another individual could shut the drill down remotely from another spot. Okay, what you're looking at right here is the operator's control panel. I guess it's obvious that I've relabeled everything in Spanish for our potential Colombian customer. What you see here is everything in the orange levers come off your primary pump. This is your rotation, your fast feed, your winch, and your wire line. Now it also has this sun valve here, which is all your secondary controls. It has a few extra valves installed for various reasons, in case you want to add a mud mixer or a hydraulic wrench or such. But it basically has your slow feed, which is your drill feed, your fine feed here, and it has your chuck foot clamp control there. And over here we have the hydraulic control for the chuck that's on the drill head. Up on the control panel you'll see that it has the emergency shutdown switch right in the center. The throttle is controlled by a toggle switch, which you raise or lower the engine RPM. We also have the emergency remote control shutdown, which is right, it's hanging on the side of the drill right now, where you can move it anywhere you want. Okay, what you're looking at here is the hydraulic foot clamp. As I mentioned, there's no jaws in there at this time because we need to purchase the jaws for our customer, whether they be NQ or HQ. Haven't decided on that yet. And in a little bit I'm going to start this drill and show you everything working. For now, we'll move up on the head and you'll see the chain case and the main rotation unit. This drill, as you'll see here in the illustration, has been incorporated to accept the Boyle style 12HH chuck, which in my opinion is a superior chuck to the nitro chuck, which was originally on this drill, where it's spring activated and pretty much 100% fail safe. It relies on oil pressure to release the tension on the jaws, but if the engine should die or it had to sit for an extensive period of time, the springs will never let go of the pipe, and you don't have no fear of losing your tooling down the hole. On this head, the lower part is, like I mentioned, a chain case, and I'm going to try and get the lube oil pump and the suction filter in another part of this video. But you can see the 4-speed transmission sitting on top of the chain case, and the Rexroth variable displacement hydraulic motor directly coupled to the transmission. In this view you can see the rotation unit, the hydraulic motor on the rotary head, and how it's connected with your hydraulic quick connect couplings. As we kind of move ahead on the drill, you'll see the main hoist, and you'll see the wireline hoist. They're on their own module on the base, the mass support. They come off as an independent unit when you're moving this rig around. In the video here you'll see those two red struts that lead from the mast frame and are connected to the rotary head. When we start it up here in a bit, I'm gonna go ahead and lay the mast down and raise it. These struts are installed to raise the mast. Once you get the mast raised into the position that you desire, if it's on an angle, you'll typically just tighten up the braces, and you'll remove those struts, and then the head's free to go up and down without affecting the position of the mast. You can see the two struts here, and they have a clamping device on them. In the position that you see them in right now, they're the 45 to vertical position. If you desire to go to a greater angle, then you'll reposition the struts to a different part on the mast. You can also see the aluminum fuel tank that's on the frame, and the black box is the 12-volt electrical battery, and it also incorporates a master switch, and it's lockable for security. Just want to add a little more information about the LF70, and some of this is coming off the manufacturer's spec sheet, so what I'm going to do is read some of this off of the spec sheet just so I can be accurate. The LF70 is one of the most recognized small format drills in the industry, and it's a flyable rig with a depth capacity of 700 meters that can be assembled in less than 1 hour with innovative modular design. This lightweight exploration rig is ideal for drilling in remote locations. It has a self-contained operator panel with manually operated hydraulic control valves. It has a 5.4 ton capacity mainline hoist. It has a 4.5 ton pullback capacity with 6 meter pull directly coupled to a feed cylinder with a 1.83 meter stroke. Hollow spindle rotation unit with 4-speed transmission. This particular drill has the Boyle style 12HH chuck, and it will run up to HQ rod. It also has a hydraulically powered rod clamp that can handle up to HQ rod or H casing. The mast can be positioned for almost any angle of drilling, from 45 degrees to 90 degrees. The drill was designed with a simple hydraulic system. Direct coupled hydraulic pumps with PTO driven auxiliary pump allows for easy maintenance. And this particular drill, when it was new, came with a Deutz diesel engine, and it has since been updated to the Cummins 3.9, which I mentioned previously. And the original design had the auxiliary pump driving off the back of the engine with a belt inside the flywheel housing, and this particular Cummins conversion now has the auxiliary pump driving directly off the auxiliary position on the engine itself, which greatly increases the serviceability of the unit, and there's no belts to worry about. On the drilling depth, this particular drill, according to their brochure, is 895 meters with NRQ V-wall style rod. In US, that'd be 2,936 feet with NQ rod. Of course, HQ rod will be a little bit, you'll have to take away from that just a little bit for the additional weight. And the horsepower on this engine is 116 US horsepower. There is a PQ head available for this drill. However, this one does not have the PQ adaptability, although it could be purchased. The rotation unit is a chain drive unit that has a multiple leaf chain drive inside the case, and it has synthetic oil in it, and it's pressure lubricated by a special oil pump and a suction filter that's attached to the bottom of the chain case. Driving the chain case is a Rexroth variable displacement hydraulic motor, and that motor is connected directly to a 4-speed Funk transmission, which the operator can select first, second, third, or fourth. First gear is 6.63 to 1 reduction, so it turns pretty slow if you were going to use rotary drilling method to at least get a casing in. Second gear is a 3.17 to 1 gear ratio. Third gear is a 1.7 to 1 gear ratio, and fourth is a 1 to 1 gear ratio. The total RPM in first gear would be 95 to 190 RPM, no load. Second gear will give you a selection of 200 to 400. Obviously, you can stop the hydraulic motor, and it should really read 0 to 400. But third gear would be 370 to 730 RPM, and fourth gear will give you 630 to 1250 RPM, depending on whether you have like I mentioned, the motor is variable displacement and is controlled from the operator's panel, so it goes from shallow to steep swash angles on the motor. So the 630 to 120 would depend upon where the operator selects the swash angle on the hydraulic motor. The maximum stall torque is 3,400 foot-pounds in first gear. Second gear would be 1,600 foot-pounds. Third gear, 700 foot-pounds. And fourth gear is 500 foot-pounds. The drill is equipped with 3 hydraulic pumps. The main primary hydraulic pump is a pressure compensated piston style pump. It develops 43 gallons per minute. Its setting is at 3,500 psi. It controls the V30 control valve. Then it also has a secondary pump which is mounted in tandem behind this primary pump. It too is axial piston, and its displacement is 11 gallons per minute. And the factory setting for this pump is 2,000 psi, and it goes to the auxiliary valve bank. And then we have last the auxiliary hydraulic pump, which is mounted to the engine. It's axial piston, variable displacement, load sensing, pressure compensated, with low pressure standby pump as well. And its primary function and its displacement is controlled by a Morris cable from the operator's panel, and depending upon the position of the lever on the pump, it controls the speed of the water pump, which is a FMC Bean 435, and its pressure setting is 2,000 psi. The hydraulic tank on this is oil capacity is 30 gallons. Now going to the drill feed and the mast, the stroke is 6 feet in U.S. terms, or 2 meters metric. The pull capacity, according to this, is 14,137 pounds, or 6,414 kilograms. Pull down, or the thrust, at 2,000 psi is 9,326 foot-pounds, and that would be 4,231 kilograms. This drill can pull 10 or 20 foot U.S. rods by utilizing the hoist. It can drill at angles from 45 degrees off horizontal to 90 degrees vertical. The mast is raised mechanically by the rotation unit, or the rotary head, by incorporating a couple of links, which I'm going to try and show here. The drawworks, the hoist and the main hoist and wireline hoist, it has just a single speed piston motor. The hook load on this winch with bear drum is 12,000 pounds. I might note at this point that it's forbidden to two-part this line. The mast isn't structurally designed to two-part, so I just had to mention it's designed for single part pull only. 12,000 pounds on hoisting drum. The hoisting speed with a bear drum is 3 feet per minute. Main hoist cable is 15 millimeters, or 0.59 inches. The maximum braking strength of the hoisting cable is 50,800 pounds, so there's a good safety factor there. Okay, it also has the high-speed wireline hoist, and it's capable of lifting 2,190 pounds, or 990 kilograms. With a full drum, it reduces the hoisting capacity to 502 pounds, which the only thing that the wireline needs to do, of course, is retrieve your core sample, which isn't anywhere near 500 pounds. Line speed on a bear drum is 3,307 feet per minute. That's 100 meters per minute. Full drum is 1,470 feet per minute, 433 meters per minute. The drum capacity with 3/16 wireline rope cable is 6,200 feet of cable, with the minimum braking strength of 5,000 pounds. It has an onboard fuel tank, which has a 15-gallon capacity. It's attached to the engine with quick connects, so that a larger tank can be set beside the drill and utilized rather than the small day tank or the small flyable tank. The drill has a hydraulic rod clamp, which It's hydraulically operated. It's a wedge type clamp. I don't have any clamps to show you for it yet, as we haven't decided what clamps the customer will require when he takes delivery of this drill. So I'm going to show it to you without the clamps, but they're basically wedge type clamps with carbide inserts. Well, that's kind of some of the information on this this LF70 portable rig. We have several others to choose from. This one is ready to disassemble and put into a container and ship to Colombia, hopefully soon. However, if this is of interest to anyone who's watching this video, this is what we do here, and we can help you find a rig for almost any application. I have another LF70 here that's just exactly like it, that's scheduled to be reconditioned. Have some underground long year drills and an LM75 and an LM90 that is also available, and we have some older long year rigs like the 44s and 38s. So if you have any questions or need any further information, please just email me. I'd be happy to answer any questions, or if you have any particular drill rigs that perhaps you'd like us to assist in refurbishing or repairing or appraising or anything like that. We do travel and do appraisals for customers and evaluations, so please feel free to contact me with anything I might possibly do to be able to help you. Thanks.